3 minutes and 40 seconds left. I'm mostly starting a little earlier so that we can kick off the audio, make sure it's working okay. Alright, so after I finished yesterday's, day 11, I went back and did a little more research and read up what people were saying on the Clojure Slack. And first of all, there's something I could have done using the same kind of technique I was already using that would have been even more optimal. And that's using like different size patches. Basically, if I summed up, if I took the frame one size below what I'm currently at, so if I'm trying to look for a 6x6 area, I could take that 5x5 square, hit all 4 quadrants, and then subtract the 4x4 square in the middle 3 times, because I would have copied that part 3 times. So that's one way to do it, and that means I only have to keep the last two dimensions worth of data in memory at any given time. So that would have been pretty fast. An even faster way is to actually do what's called, what was it? Grid sum something. There's something, basically the idea is you take each square in this grid becomes the sum of all squares to the left and up of it. So given that you can calculate any size square in the grid by just a little bit of mathematics and adding 2 and subtracting 2. So basically you have a sum of 4 calculations you have to make each time, and the amount of memory that would take is fixed, and the amount of complexity it would take to calculate it's fixed. So it's might be more efficient. I might go back and implement that in Clojure because that should stick just fine. Here's hoping. Oh, well, anyway, we have a minute left till day 12. Let's see what challenge they give us today. It's actually been kind of algorithm heavy this year, which is neat, but I'm also not prepared for it. So a lot of these kinds of algorithms don't come up that often outside of, you know, either toy problems or at least in very specific domains. So that last one, all those convolutions, that's a graphics-y domain kind of thing. You'd use filters like that all over the place in graphics processing or image processing in general. I'm sure there's other use cases for it, but that's one of the most common known. Maybe signal processing or something. Alrighty, we have our workspace set up. Five, 4, 3, 2, 1. We're in an underground network of caves. I discover a long tunnel that contains a row of small pots. As far as I can see, few of them contain plants. The pots are numbered with 0 right in front of me. To the left, the pots are -1, -2, -3, so I'm on a number line, basically. And I have an input of 0, 1, 2, 3, 4, 5, etc. This is going to be a automata, isn't it? Yeah, this is going to be a finite state automaton. So we're going to get a set of rules, I'm guessing, and we're going to have to apply those rules over and over and over. A given pot has or doesn't have a plant on it based on whether that pot had a plant in the last generation. So, I'm looking at the two pots to either side, and I'm deciding whether this one lives or dies based on the pattern that it matches. Okay. So, standard finite automaton. Okay, after 1 generation, only 7 plants remain, etc. After 20 generations, the pots shown as contain plants. After 20 generations, what's the sum of all the numbers of all pots which contain a plant? So, yeah, standard cellular automata imitation. Ooh, this is going to be fun to parse. Okay. Let's write that out. We'll write this down. Okay, let's go ahead. Let's see. Initial pots. There we go. We're going to go ahead and drop count of initial state. This is a really clumsy way of doing it, but it's also going to be really effective. The first line of our input. Whoops. Let's go ahead and split this into lines. Splits, and that's a string by regex. Alrighty. And just to verify, what's our initial pots look like? Looks good to me. And then our rules are going to look like let's do defen first. Parse rule of a line we're going to let pattern result be the result of matching this regular expression with the line, where the regular expression is 5 times, either a dot or a hash 5 times, then that, I don't think the equals is going to be an issue here. And then either a dot or a hash. In okay, parse rule int of input 3. We got our thing, looks good. Okay, I like it. Our rules are going to be the result of mapping parse rule onto the result of dropping the first line, which is our initial state, and our empty line in between of our input. Let's check our rules. Looks good to me. Okay. Let's go ahead and turn this into, instead of a pattern and a result, we're just going to turn this into pattern mapped to result. And the reason I'm making this change is so that we can do input drop 2 map parse rule into a map. Did I run this? There we go. Whoops. Great. So this will actually make this much easier to look up. This probably doesn't cover all the cases. So, what do they say? Only the combinations which do produce a plant are listed in this example. See. So it doesn't specify, I think, what happens if there's no matching rule. Are all the rules accounted for? How many would that be? 25, I think. Oh no, it's 32. Right, because we have 2 to the 5, not 5 to the 2. Silly me, okay. So that should be actually all the rules that we need then. I think one of the key issues I need to recognize here, though, is that my automaton may spread outside the initial. So what I need to do is make sure there's 2 dots at the edges at all times, and I can expand or contract that as needed, except, oh, the numbers have to still match. So I also need to know when I add something at the beginning, for example, I need to know what my current base is. So the idea here is that if my plants spread below 0, I need to be keeping track of those pot numbers too, because those are going to be part of our sum. So if I tack on extra things, I need to know that, oh, now I'm looking at -2, -3, -4, etc. So I need to know what the beginning of my list is at all times. It's a little bit of a wrinkle in this guy, but I think we'll be able to handle it. So given that, actually, let's define pad pots. There we go. So given the line of pots, this is where some airline pattern matching would be nice. Pad front, let's call it that. So if our first 2 pots, oops, not first 2, take 2 pots. There we go. Then we just got pots. This might read a little better. Okay. Oh, come on. Defen pad front pots of pots. Let's just extract this to its own function. Let's just grab all this. If it's so we're just making sure we have 2 dots at the beginning, at the very minimum. Min index. There we go. So now we actually have to return something more interesting. Pots and min index. We're going to return this and minus min index 2. So we're expanding it 2 to the left, basically. That matches. You could probably do this in a little bit of a simpler way, but for now I'll stick with the declarative. And hash hash also this. Probably swap our cases here. Come on. Okay. That reads nicely, I think. That reads very nicely indeed. Okay. That looks good to me. Now if we have a dot at the beginning, just adds 1 more dot. And if we have 2 dots, and if we just have 2 hashes. Cool. Okay, I like that. We could do something similar for padding the back pots, except we won't have to worry about the index this time. And the reason for all this will become very clear soon. There's like drop something, I think, that gives you the last in items. No, it's not that. But last, but that doesn't give you an integer. take last. There we go. You say take last to pots. We're gonna go ahead and kill rectangle. I need to learn the key shortcut for that. Okay, so if it's dot dot, we've got pots. We're gonna have to actually swap around our arguments this time. Pots, pots, pots. That can almost definitely be compacted a bit, but not worrying about it for now. I like it when you can describe things using basically table structure here. Oh, I did do it backwards here. My cases aren't the same. I need to have the last two here. These two cases actually swap themselves. So I need to make sure I'm accounting for that. There we go. Gotta be more careful. Let's go ahead and pad front pots with padding the back pots of pots. And min-index. So if I pad pots of hash hash dot dot hash dot and 0. Great. Good. Okay. That's exactly what I'm looking for. Okay. Deafen gen plants. So given a generation of plants, I could describe it using an offset instead of a strict index, but for now I won't worry about that. We're going to pad our pots. We're going to say, see, yeah, we're going to say our patterns are partition. So this should be familiar. What we have done is we've actually said each of the regions that matter let me validate something real quick. Basically, what I want to make sure I haven't done is that by prepending so say I had like 3 blank dots in a row. Yeah, it should be dead. 3 blank dots at the end should also be dead. Okay, I think we haven't changed the state any. I think we're safe. Okay, so we'll find out. I'm fairly certain these are going to be well-behaved rules, such that extending it with zeros won't cause problems. I think that's implicit in the problem statement. So we're going to partition this into groups of 5, offset by 1. So we're just taking, for each plant, basically, now that we've padded it around it, we're taking each plant and we're saying, give me the 2 on either side, and I think we're safe, yeah. No. Shoot. If we don't pad 2 to the left immediately, we're going to lose 0, funny enough. Oh, no, I won't. Hold on. Okay, what's interesting about this, so I'm getting in a Newman index, but I'm only going to count the ones that are within my partition. So really, I'm starting at this Newman index plus 2. And if that means I go up 1 or down 1, that's fine, I think. We'll find out. The way I'm trying to visualize this is, say I start at 0, with 0 here, and I don't need to pad it. And then I have 2, 3, 4, 5, 6, 7, etc. If I start partitioning, it'll partition starting with this is my center one at 2, not at 0. So if I say, oh, this one grows, this one doesn't, etc., all the way up, 0 gets left behind. But I think, is that okay? Looking at the patterns of my rules here. Where's my .hash? It's right there at the top. It's almost... You know what? I might have worked myself into a hole here by making bad assumptions. I need to be more careful. I'm pretty sure I actually just want to unconditionally prefix it with ... Interesting. Okay, let's try this, actually. I like where this is going, so... So we're going to let our padded pots be... be concatenating those 3 things together. Our Newman index is this. We'll see if we need that later. this guarantees that when I do this partition, that I'm getting at least the current set of... No, it's even weirder than that. So, let's say I'm given something where 0 at the beginning, like I have here, is a hash. That means it can influence up to 2 pots away. That's to -2. And so I need to actually pad 2 outside of that. So actually, this is even... Cat... def... Okay, we see what we're doing here? Padding, pots, padding. Just to make sure this is going to behave as intended. Looks good to me. Okay. Alrighty. Partition that into sequences of 5. New pots are the result of mapping this against our rules. Okay, looks good. Let's see. First, a result. That should mean we get a character out, just so we're keeping things consistent. I don't want to risk having strings throw things off here. So the first of our rules is now better. Okay. Be consistent in your types, folks. Okay. Mapping our rules against our patterns. That should spit out our new row. Defin trim pots. Given the line of pots, split pots be split I think split width takes a predicate. I don't necessarily want that. Split with this is going to be blank pots and rest pots. Oops. We're gonna say trimmed pots will be just making sure things are consistent here, because I have a suspicion we will want this. Drop while the last element is dot, so we're just trimming stuff off the end. This is a kind of a clumsy way to do it, probably. Hots. The negative of the count of the blank pots at the beginning. This is going to tell us, whoops, how many things we trimmed. Okay, let's try this with trim pots of how bad is it spit with? Our pots. There we go. Hash hash dot hash. And we trimmed 3. Okay, good. Looks good to me. And this gives us back whoops, I should okay. That gives a nice result, I think. And then from this, we are going to return our trimmed pots, and we're going to add to our new min index the number of pots we trimmed off the front. Okay. I think that looks good. So let's just see what happens for our initial pots with the min index of 0 currently. Does not like. Still does not like. Okay, where's that happening at? Map V. Oh, you know, it helps if I give this something to work with. Our padded pots. Okay, looks good to me. After 20 generations. So see, so what we're going to do is we're going to iterate something where we apply gem plants to our argument with these two initial arguments right here. That'll give us back a new generation, which we then keep stacking over and over and over and over. Starting with generation 0, so we're going to drop 20 from this. I'm going to take the first take this better. Let's go ahead and toss down this line. What's Gen 20 look like? Reasonable, I think. Interestingly enough, it has slid to the right, not the left. So hopefully that's correct. Hopefully I haven't done something horrible here. So now we need to figure out how to number these. I think we can just do map into a vector, and the vector will contain first the elements of Gen 20, and second, oops. Come on. Okay, range starting at the second of Gen 20. which is our initial index. Let's do that instead. I don't know, is that going to accept? It does not like that. Okay, whoa. Yeah, this will do. Filter this by okay, and then we're going to go ahead and map seconds. We're going to get all the actual pot numbers, and we're going to reduce it to a sum. Go. 41. It doesn't sound right. We'll find out. Not the right answer. Do. Okay, let's take a look again at our initial generation just to make sure we are actually behaving reasonably. Okay. For comparison. Okay. So it says we've drifted one to the right. So really, this is this. Oh, not that. This is this. If we're going to line things up well. So this would be dot dot hash hash dot, for example. Which is a dot, correct. This would be dot hash hash dot dot. Which is a hash. This would be a hash hash dot dot dot, yeah. Dots. Hash dot 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 dot. Easier to find. Okay, so I think I'm fairly confident in this. Oh, wow, I'm counting the exact wrong thing. I'm an idiot. That almost makes me less confident. See this? Oh, hold on, there we go. Does that look like... So that's like 12 plus 13 plus 14. Something's gone really wrong here. Let's just take this alone. That's what I thought. See that? That's all wrong. Oops. 12. So what am I missing about range? Oh, that's end. But if I don't want an end... Okay, you know what? You know what's easier? Oops. Then this. Drop this many of range. There. Ha! That seems more reasonable. Okay, there's part one. Not great, but not terrible. Now we have to do it after 50... Oh, how many is that? 50 billion generations. Okay, def, gen. Okay, we're doing this. I really hope this doesn't blow my stack up. I think it shouldn't, because if I am dropping... Oh boy. Okay, fingers crossed. This is going to take a bit. This is where we find out just how slow things are, yet again. How bad is my algorithm? Womp. The expansion didn't seem terrible. This is a case where I'm not going to be able to see what kind of progress it's making without adding explicit side effects here and there. I should probably create a function or macro that lets me, like, intersperse periodic side effects without screwing up an overall structure. Maybe it's a good transducer. Worst case, I ditch this again and I try trampolining. Do I really need that much padding? Yes. Yes, I do. Okay. Hmm. Okay. What? Okay. So, let's see here. Couple things I can think of. Let's kill these. So I didn't end up needing any of this, so I can kill this. Let me think here. I'm going to go ahead and comment this guy out just so we're not running it accidentally as usual. Bum, 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 bum. Validate how PMAP works. The overhead for PMAP might be too great, honestly, for this. I'm not sure that's the case here, so I'm going to leave that be. Instead of using iterate and drop, let's try rewriting this using a trampoline. That's for mutual recursion usually. I think loop uses tail recursion. To hack so that something like tail recursive optimization works. So I'm going to do this in a slightly different way. Let's see, wait. Pots and index is initial pots and 0. Okay, let new gen be applied gem plants you know what? Let's just take out that bit of destructuring so we don't have to sit there and apply every time. Similarly here, I think actually, loop pots is pots if right, not an insider. Should probably turn that back on. Trim end of rest pots. Looks good to me. Okay. Ink, Gurgen, in, if So if the new gen is the target gen, then the new pots and index. Otherwise, recur with the new pots and index and the new gen. Did not like that. I should probably actually run this. Whoops. $23.49. And what happens if I run pot gens? $23.49. Just like that, we now have a replacement that is using loop recur and might be a little more efficient, and that's a vague might. Here's hoping. Let me check something real quick. We know this isn't int. Is it going to let me do this? It is, but it doesn't know that num trimmed front isn't int, and it might not let me do this. Okay, it does like that. Anything else to complain about? Surprisingly, no. So that was our only boxing complaints. Oh, I'll take that. So that makes me a little more confident that maybe this will run quickly. Well, let's take our definition here. Run pot gens initial pots, and how many times we're going to run it? Way too many is the answer. Are we ready? Let's try this again. Drum roll. Well, something anyway. This is another one of those things where we're probably going to want mutability, honestly, in the end. Because what we kind of want is to rewrite as we go. Okay, someone mentioned something that makes me realize that there is probably, as usual, a quirk to this. So what I'm going to do is I'm going to kill my REPL. Ready for this? This is pretty obvious once you realize it. So, if the new gen is the target gen, or new pots and index is equal to and index see it now? So what we're saying here is, hey, if the pattern is stabilized, if the pattern hasn't changed at all, then we'll go ahead and halt. It does help if I actually write things in the right order here. Okay. Let's go ahead, kill this. Fingers crossed, right? Hopefully it stabilizes quickly. Ripple's taking a bit to start up today. There we go. Let's make sure once again that we commented this out. Oh wow, I should probably make sure. If I read this correctly, it's actually stabilizing at generation 18? Whoops, I used the wrong one here. Not that big a deal. I mean, it's going fairly fast. It's not, you know, 5 billion? 50 billion fast, but it's fast. Okay. Just get an idea of if it's growing, and if so, by how much. Might need to bench this. Seeing a pattern here? It's drifting off to the right. I think I see it. Okay, so given that, I bet that's the same pattern too. So you do really have to actually examine this as it goes in order to really understand what's going on. Okay, so given that, I'm going to let it run for $10,000. $10,001. Just to be on the safe side. Let me just kill all these for now, so I can run this thing. Oops. Okay. Okay, so whoops. Okay. There it is. So the pattern appears to be indeed remaining static. There's no like wiggling variations in between. Okay, so let's just make sure I got that right here. So this is whoops. This is the first of Gen 10,000. There's something I can do with this, honestly, and I'll figure it out later. But it will actually be able to tell me what that offset is, so in case it was, like, say, shifting by 2 for some reason, you can measure that. I'm not sure that would even happen with this kind of automata. I think it would have to be wider for it to shift by that amount. That said. So first... minus that's how many more would have to go. And then this is the offset it will be. So we are artificially creating this. still a very large pattern, apparently. I think. Seems odd. I know it's 140 wide. It shouldn't be that much pain. Oh, you know what it is? It's dropping the first... it's dropping the first 50 billion of the range. It's taking so long. Okay, so let's do this also with the loop recur. Good grief. This shouldn't be this hard. Some filled pots. Pots. Min index. Loop. Pots. Pots. Platinum. Min index. We're going to recur with the rest of our pots, incrementing our pot number, and plus some platinum. Otherwise, Okay. Some filled pots first. Oops. Apply some filled pots to our Gen 20. 2349. I like that result. That's the same as we expect. Okay. Let's go ahead and apply some filled pots to our Gen 50K, 50B. Okay, that's better. Let's just make sure I haven't done a typo. We got it. And actually doing okay, about the same in the first and the second, so it seems other people were having issues too, about the same pace. Alrighty. So this is something to note. Happens a lot of advent of code, something to keep an eye on. If the numbers seem too big to process and there's no way you could get that kind of speed, chances are there's something like this, where there's a fixed point or a cycle or at least some pattern where you can weasel your way out of actually doing the calculations. So always keep an eye out for those. That said, I like how this turned out, and I like how it ended up reducing down to the point where you could easily solve it by hand. Part 1 solution. Part 2 solution. Cool. I am going to kill this though. We don't need all this. And that's an extra. There we go. I'm going to get rid of the OR statement here. Doesn't make any sense. Again, I could optimize it so it just finds when the sequence is the same and stops there. I'm making an assumption about how far it increments, which is what I talked about earlier. For now, I'm okay with this. If I was going to benchmark this, I would generalize it so that I could put this alongside other folks' solutions. As it stands, I feel okay with this. I will put a note to myself here. Stop, halt recursion when pattern reaches fixed point. I don't know why it does that every time. Find okay. That said, I'm happy with how this is. let's go ahead and commit, and we'll be good for the night, I think. Stage, commit. Add day 12 solutions in Clojure. Alrighty. Cool. With that, I think we're done for the day. I'm going to go ahead and take off here. Oops. Don't look. Don't peek. No peeking. I saw you peeking. Okay. That should do it for the day. I'll wrap it up here and see you tomorrow, hopefully. As always, have fun with Avenue Code and keep learning languages, especially Clojure.